Okay, so let's look at question C again from the graphs of derivatives worksheet. So I've just done a rough sketch of the function here. Now what we need to remember is, remember when we're solving quadratic equations, we're looking for these 2 points where the actual function crosses the x-axis. And we can end up, depending on the function, we can usually end up writing down our solution or the actual function as something like, I'm just going to write a random one, so like x plus 2 times x minus 1, for example. And so like if we multiply that out, we end up with x times x, which is x squared, x times minus 1, which is minus x, 2 times x, which is plus 2x, plus 1 times minus 2, which is minus 1, and that equals x squared minus x plus 2x, is just plus 1x minus 1. So this is the same as this. This is the more simplified version. And so, for example, this equation, which is the same as this, would cross the x-axis at x equals minus 2, so somewhere over here, and x equals 1, so somewhere about here. And that's because, remember when we're solving, these points where it crosses is where y equals 0. So if this was a function y equals x squared plus x minus 1, then what we're doing to solve is setting y equal to 0 and saying y equals 0 equals x squared plus x minus 1 to find these 2 points where y does equal 0. And that's the same as, we already know that this is the same as this, x plus 2 times x minus 1. And the only way for this to be 0 is if we set x equal to minus 2, because you would have minus 2 plus 2, that would be 0 times whatever this would be, it doesn't really matter, but we would be minus 2 minus 1, which would be minus 3, but anything times 0 is 0. And if we set x equal to 1, this would be 1 plus 2, 3, but this would be 1 minus 1, so that would be 0 as well, making the whole thing 0. And so we can use this, and look at this way of writing it, and then these points here. Right, so we know, first of all, the quadratic is curved in this direction, which means it's negative. If it was positive, it would be curved in this direction. So we know there's going to be a negative. This x squared term here will be negative for this function. So we're going to have, how I would do it is just start writing it like this. So this is C now that we're working on, this actual function here. I would start writing it as x, it's going to be x plus or minus something, times x plus or minus something else. But we know already that one of these x's has to be negative. Let's just make this one, because when we go x times x to get our x squared term, it has to be negative x squared because of the direction of this curve. And for our first one, it's easy. Y equals 0 when x equals 0. So there is actually no term here. We can just put plus 0, for example. And you'll see that why that's a bit clearer in a second. And then our second point where we cross the x-axis is 4. So meaning if we set x equal to 4, this whole thing has to equal 0. So this term here will be minus 4. Because then we'd have, if we set x to 4, we get 4 minus 4 is 0. Right, so we can get rid of that 0 and just write it as minus x times x minus 4. Now we need to double check also that that's going to work with this point. Right, so when x equals 2, y should equal 4. So we can write this out, and we can expand it. So minus x times x is x squared, minus x squared, sorry. And then minus x times minus 4 is plus 4x. And so let's say that equals y. It's our function. So let's say y of 2, so y when x equals 2 is going to equal this, so it's going to be minus 2 squared, because we're substituting 2 in for x, plus 4 times 2. That's going to equal minus 4, because 2 squared is 4, plus 4 times 2, which is 8, and that equals 4. So that works. So we know that our function y is equal to minus x squared plus 4x. Now all we have to do is differentiate and figure out. We already figured out that it's 0. The derivative is 0 at the point 2, 4, at the point x equals 2, right? So let's just start with drawing our graph again, how we had it. So instead of being y, this is now y primed that we're graphing as a function of x. And we know at the point, let's say this is the point 2, x equals 2. We know that that's where the derivative is equal to 0. This is the derivative equal to 0, so the line passes through there. Now we can just differentiate this, right? So let's just do it down here. Y primed. Bring the 2 down in front, so it's going to be minus 2 x to the power of 1. Bring the 1 in front, and that's going to be a 0 there, so plus 4. Now we can just sub in any value of x that we want to get our second point. Let's say x equals 0. Oh, it's going to be 4, right? So y primed of 0 when x equals 0 is equal to minus 2 times 0 plus 4. So that goes to 0. That equals 4. So let's say 4 is up here. So we know that our derivative passes through there as well. Our derivative is equal to 4 when x is equal to 0. And if we just have a quick look at that, that's going to be a negative slope. And that's what we said it was going to be, because it's a large positive slope here that gets closer and closer to 0 and then goes negative. So the slope the whole time is going from left to right. The slope is going from a large number to 0 to larger negative numbers. And so if we look at this slope as well, this is our derivative. It starts at large positive numbers, like we said it is down here. Goes to 0 at 2, so the slope goes to 0 at x equals 2. And then after that, the slope is negative. And after 2, we go into negative values of y primed. I was just going to say, I don't know how much detail your teacher wants you to go into. If they want you to figure out this exact graph of the derivative exactly like I have here, but I assume that's what they want you to do. So I'll leave that one there, and then eventually I'll do some more videos on the other ones because they're a bit trickier, because some of them are cubics as well, so you have to figure out the function for the cubics.